Welcome to my YouTube channel. I am Professor Sachin Kare. Before start this video, please like and subscribe my YouTube channel for various interesting content. Thank you. Let me start very important topic in statistics, linear regression analysis. Content of this video: introduction, correlation and regression, linear and non-linear regression, some definition like least square method, covariance and standard deviation, lines of regression. We are going to see derivation of lines of regression of y on x and x on y, angle between regression lines, coefficient of regression and properties of regression coefficient. We'll see first introduction, correlation and regression. The word correlation is made of co and relation, that is together. Definition of correlation: it is a statistical tool that helps measure and analyze the degree of relationship between two variables. Example of these: income and expenditure, price and demand. On other hand, regression is how one variable affects on another variable. Is nothing but a regression. Essentially, it is a cause and effect. It implies that one outcome is depend on another variable. Regression analysis helps to determine a functional relationship between a two variables, x and y. Here, x is an independent variable and y is a dependent variable. Regression is nothing but to draw the best fit line among these points. The points on these lines are called as estimated points and actual is apart from that. So difference between these is act as an error. We'll see the difference between correlation and regression in the form of meaning. A statistical measure that defines correlation or association of a two variable. It is a correlation. Regression describes how an independent variable is associated with a dependent variable. Dependent and independent variable in correlation, there is no difference. In a regression, both variables are different. Uses to describe a linear relationship between two variables, and in regression to fit the best line and estimate one variable based on another variable. Objective of a correlation to find the value expressing the relationship between variable, and objective of regression is to estimate value of a random variable based on the value of the fixed variable. There are two types of the regression models. First one is a linear regression and second one is a non-linear regression. The dependency of the output of the input is defined by a linear function. In this graph, the straight line is there and these points are output of this point is depend upon the input of this point. Okay. In a non-linear, dependency of the output is not depend upon input. That's why it's called as a non-linear function. Now we'll see some definition which is very useful in the derivation of the lines of regression. First is a least square method. It works by making the total of a square of the errors as small as possible. That's why it's called as a least square. In this graph, x line is there, y line is there, and different points are there. So we are interested to calculate these line, the best fit line. So we are going to draw this line in such a way that this line is very close to all the points and the error between these points as small as possible. So the straight line minimizes the sum of the squared error. So when we square each of these errors and add them all up, the total is as small as possible, the line as close as possible to all points. In this graph, x and y, two variables are there and we draw a line, best fit line. The point on this line is estimated points and this one is the actual point. So difference between these two lines are called as a error, E1. That is yi minus y1 dash is E1. This is error first, error 2, error 3, so on. And addition of all these error square should be the minimum. This is the least square method. This is given by this formula: summation of I is equal to 1 to n yi minus yi dash square is equal to summation of I1 n ei dash square. Next definition is covariance. Let we consider n pair of observation of a two series x and y. x1, y1, x2, y2 and xn, yn. So deviation of x values from their mean x bar are x1 minus x bar, x2 minus x bar, so on xn minus x bar. This is similar to y value also. So the sum of n products divided by n is defined as a covariance of x and y and denoted by covariance of x and y. So this x minus x bar is a deviation of a point x1 from their mean, and y1 minus y bar is a deviation of a y1 point from their mean. So we are taking the product, and the addition of all product divided by n is a covariance of a x minus y. After simplifying this equation, we'll get covariance of x comma y is equal to 1 by n summation xi yi minus x bar y bar. Last definition is standard deviation. It is defined as a positive square root of the arithmetic mean of a square of the deviation of a given value from their arithmetic mean, and it is denoted by a sigma. So sigma is equal to under root 1 by n summation of xi minus x bar square. So here this bracket xi minus x bar is a deviation of a xi point from their mean. This equation also given by square root of summation of xi square divided by n minus x bar square. Now we'll see derivations. The aim of the regression to find the best fit line, and the best fit line should be that line which is very close to the all point in the scatter diagram. So we are interested to draw the line on a scatter diagram. The equation of a line is obtained by a least square regression analysis. So there are two derivations: derivation of a line of regression y on x and x on y. We'll see that. Here we'll see first derivation of line of regression of y on x. Here y is a dependent and x is a independent. So we are finding y for known value of x. As this is the straight line, we know the equation of straight line is equal to y is equal to mx plus c, where m is a slope and c is a intercept or a constant. We are interested to calculate the value of m and c, and then we put over here. That will become derivation of the line of regression y on x. So in this graph, there is x and y variable. That line, straight line is there. Actual point is a y1 and estimated point is a y1 dash. So difference between this is denoted by e1. Again we are applying least square principle. So yi is equal to actual value of y, yi dash is equal to estimated value of y. So yi dash is equal to mxi plus c, and yi minus yi dash is equal to the error in estimation by least square principle. So least square principle gives here y1 minus y1 dash square plus y2 minus y2 dash square and so on. That is equal to f is equal to summation I is equal to 1 to n yi minus yi dash square. So we just put value of yi dash, which is in equation number 2, in here. That will become f is equal to summation I is equal to 1 to n yi minus mxi minus c square. So by using least square principle to minimize the sum of the square of the difference f between yi and yi dash by differentiate with respect to m. So we are taking a differentiation with respect to c and m. We'll take one by one. First we differentiate this f with respect to m, that is partial derivative d by dm of f. So 2 in bracket yi minus mxi minus c, partial derivative of minus x minus mxi is equal to minus xi is equal to 0. So this minus and this 2 goes on a right side. So this equation finally becomes summation of xi yi is equal to m summation xi square plus c summation xi. This is the equation number 4. Now we'll differentiate f with respect to c. The partial differentiation with respect to c, it means m is a constant value. 2 in bracket yi minus mxi minus c, derivative of minus c is equal to minus 1. So this minus and this 2 goes on a right hand side. So ultimately the equation will become summation of yi minus mxi minus c. After multiplying this summation inside of this bracket, equation become summation yi minus m summation xi minus nc. This nc is nothing but summation of c is equal to nc. Now we rearrange this equation for a c, that is equal to summation yi divided by n minus m summation xi divided by n, and we'll get the value of a c is equal to y bar minus mxi. Now we put this c value in equation number 4. This is what equation number 4 we are already calculated it, and we put this value c is here. After putting and simplifying this equation, we'll get the equation summation xi yi minus n x bar y bar is equal to m in bracket summation xi square minus n x square, or 1 by n. We just take common 1 by n and the equation becomes this. So we know that this left hand side portion is a covariance and this one is a standard deviation formula. So covariance is equal to 1 by n summation xi yi minus x bar y bar, and standard deviation square root of summation xi square divided by n minus. So we just put the value of covariance and the standard deviation in equation number 6. So it will become covariance of x comma y is equal to m variance of x. So this is what m value, m is equal to covariance of x comma y divided by variance of x. Now we get m value and c value, and that both value we put in equation number 1, that is y is equal to mx plus c. So we put c value here, y bar minus mx bar, and we are simplifying this equation for line of regressions. Y minus y bar is equal to covariance x comma y variance of x in bracket x minus x bar. This term again represented by r, standard deviation of y divided by standard deviation of x, or byx. So here byx is nothing but a regression coefficient of y on x, and this is the equation of line of regression of y on x. Similarly, we calculated derivation of line of regression x on y. Here we take y is equal to ay plus b, where value of b and a we are already calculated, and this bxy is here regression coefficient of x on y. So this is what the derivation of x on y and y on x. Now we'll calculate angle between regression line. Here are two lines, regression line y on x and regression line x on y. Both are a straight line, and angle between this line theta is called as an acute line. So the angle between these two regression line for two variable x and y is given by theta acute angle, which is given by tan theta is equal to mod in bracket 1 minus r square divided by r, another bracket standard deviation of x multiplied by standard deviation of y divided by variance of x plus variance of y, where r is correlation coefficient, sigma x and sigma y is the standard deviation of x and y. Now the coefficient of regression, as we know that line of regression y on x is given by this formula. So this byx is coefficient of regression of y on x, and the line of regression of x on y is given by this equation, and bxy is coefficient of regression. Now the last point of this video is properties of regression coefficient. As if both the regression coefficient bxy and byx are negative, then correlation coefficient r is negative. Arithmetic mean of regression coefficient is greater than correlation coefficient, that is byx plus bxy divided by 2 is greater than r. Coefficient correlation is a geometric mean of a regression coefficient. R is equal to under root byx dot bxy is less than or equal to 1. If one of the regression coefficient is greater than unity, another is less than that unity. As R is a geometric mean of byx and bxy, that means R is lies between byx and bxy. If R is equal to plus minus 1, then byx is equal to 1 by bxy and vice versa. If standard deviation of x and y are same, then regression coefficient of byx and bxy is equal to correlation coefficient. If r is equal to 0 means there is a no correlation, or we can say that variable are independent, then tan theta is goes to infinity and theta is equal to 1 by 2, theta is equal to pi by 2. Then line of regression are perpendicular to each other. If r is equal to plus minus 1, that means correlation is perfectly positive or negative correlated, then tan theta is equal to 0 and theta is equal to 0 or pi. That means that the two lines of regressions are parallel to each other. In this way, we learned very important topic in statistics, that is linear regression analysis. To encourage for new content, please like and subscribe my YouTube channel. Thank you.